So I just wanted to go over another example of stoichiometry. So instead of going grams to grams, which we've already done, how about a problem that involves moles to grams? Okay, so an example of this type of problem would be how many moles of oxygen would be produced from 50 grams of potassium chlorate. So we've got a moles problem, we've got grams to start with, so let's talk about this. So first thing we need to do is we want to match up what we're looking at in our balanced chemical equation. So of course we've got oxygen here. This is what we breathe. And here we've got the potassium chlorate. So we know from our balanced chemical equation, the numbers in front mean the number of moles in our recipe. This is just like if there was a dozen, this would be 2 dozen. Moles is just a way to count. If this was pairs, it would be 2 pairs, but we're in chemistry, so our numbers in chemistry we call moles. So 2 moles of potassium chlorate will produce 2 moles of potassium chloride and 3 moles of oxygen. So we're going to be focused on this 3 and this 2. This is going to relate these 2 different chemicals together. Okay, so we got to get to somewhere to use these moles. Okay, and so we've got grams to start with, so let's go ahead and start with that. And you know what, actually let's start by listing our knowns. What do we know? So we know from the balanced chemical equation, we know that 2 moles of KClO3 equals 3 moles of O2. And so I didn't do anything there that involved no math. It was just taking this 2 and this 3 because that's the information that the balanced chemical equation will give us. Make that 2 a little bit better. Okay, what else do we know is that we're given, so we know the mole-mole ratio there. We also know that we have 50 grams of potassium chlorate, and because we know our polyatomic ions, we know that K is, in our periodic table, we know K is potassium, ClO3 is chlorate, so we're really good there. And from the periodic table, we can also figure out, if we add up the molecular masses of K, 1K, 1Cl, and 3 O's, we know that the molecular weight of KClO3 is, look it up here, because I did that in advance, is 122.55 grams per mole. And what that means is that if we have 1 mole of KClO3, that is going to weigh 122.55 grams. We also know from the periodic table, and maybe we'll use this, maybe we won't, the molecular weight of O2, it's good practice anyway, is 15.99, which is the mass of 1 O, plus 15.99 grams per mole, which is the mass of 2 O's from the formula. So that's going to be 31.998 grams per mole. And what that means is the same. 1 mole of O2 is going to weigh 31.998 grams. So if we had 1 mole, it'd weigh about 32 grams. If we had half a mole of that, it'd be about 16 grams, and so on and so forth. It's really a ratio. So these are some potential things that we should think about, some potential conversion factors, okay? So anytime you have conversion factors, maybe you should write a little box around them. Okay, so now let's go ahead and start setting up our ladder. So we know we've got 50.0 grams KClO3. We know that from the balanced chemical equation, the only way that we can relate 2 different chemicals is by getting them to moles. So ask yourself, is this moles? No, it is not. So we can use the molecular weight to find moles. And that's this one right here. The molecular weight of KClO3 is 122.55 grams per mole. So we know we should put the grams on the bottom, grams KClO3, and then we can put 1 mole on the top of KClO3. And by doing this, we're going to be able to cancel out grams of KClO3 with grams of KClO3 because they're identical. And now we have moles of KClO3. Because anytime we want to compare two different chemicals, we want to do that by comparing numbers, and moles is the way that we count. Moles is the numbers. Grams are masses. Those are not numbers. Okay, so now we want to convert moles of KClO3 to moles of O2. And we're going to do that with our balanced chemical equation, which we already thought about. So we've got 2 moles of KClO3. It's going to react with, or is going to produce 3 moles of oxygen. So that's the ratio that goes right here. 2 moles KClO3 is going to give us, or is going to produce there, 3 moles of O2. And because in this question we want number of moles of O2, we can now stop because the units we have left are moles of O2. So we do not need to calculate the number of grams of this. That's not what the question's asking. We are all set. So you multiply on the top 50 grams times 1 times 3. Divide that by 122.55. Divide that by 2. And that's how you figure out your answer. So your answer is going to look like 0.6122 moles of O2, but because you're given something with 1, 2, 3 significant figures, probably keep it at 3 significant figures. This one has 1, 2, 3, 4 significant figures, so 0.612 moles of O2 is a good number of significant figures. And we are all set. So that's an example of stoichiometry involving grams and moles.